Something that we still don't know very well is understanding why is it that only humans have language. So many of the cognitive prerequisites, we always find them at least in some species, and in particular so in our very closest relatives. At least part of the answer has to do with how we interact with each other, because humans really stand out as being gifted hypercooperators with a prosocial psychology. In this work package, what we like to do is to systematically address this possibility that this way of prosocial interaction acts like a driver to push towards more and perhaps even more complex vocal communication.
We want to bring two big questions together. The first one is why are humans so cooperative? Because we are more cooperative than any other species we know. And the second is that we have this very highly evolved communication system called language. We strongly predict that language makes us this highly cooperative species that we are.
So to achieve this, we will use different approaches. One important approach is that we do very broad species comparisons where we collect behavioral and also vocal data from species that vary with regard to how interdependent their lifestyles are. A very particularly intriguing test case is also the contrast between autistic and neurotypical children, which Marie Scher from Geneva will contribute. This brings in also a very important comparative neuroanatomic perspective, which will be covered by Paola Cerrito from Zurich. And last but not least, we can look at this also within species by comparing groups that live in more or in less interdependent societies and see how this impacts their communication. We can do this with the marmosets at Primate Station because as humans, they fundamentally depend on each other, on their group members, to successfully raise their offspring. This interdependence influences how they interact with each other and also how they communicate to coordinate and have such a prosocial psychology, much more than other primates. But we can also do it with humans, and this will be done by Redouan, Diana Mazzarella and Adrian Bangeter in Neuchâtel, who will be collecting data from different human societies across the world that differ with regard to interdependence.
We will conduct experiments that are based on game theoretical ideas. Typical experiments using game theory on humans, they don't let humans talk to each other. Because of these reasons, we don't really see the full cooperative capacity of humans. What we consider very interesting in our experiments is that we will borrow from known examples of animal cooperation. Our main study system that we rely on is the cleaning mutualism involving the Cleanerus labroides dimidiatus. That's a little fish that lives in the Indo-Pacific. They remove ectoparasites from other fish on the reef, so-called clients. Important component of these interactions are that there's reputation, there's a market that clients can choose between different cleaner fish, there's the possibility of punishment, that clients stop an interaction or become aggressive towards the cleaner fish. And we will simulate such interactions in human games and see what humans do, whether they are good cleaners or not.